All right, ladies, gentlemen, and everything in between. My name is Benjamin, but you can just call me Ben. All right. Fractals. I know that there's a lot happening on your screen right now, but let me tell you. All right, sit down, buckle up, because it's about to get nuts. All right. And you know what? You're probably like, all right, Ben, nice to meet you. What am I even looking at? Well, boy, oh boy, do I have a present for you. I hit the wrong button. Bear with me. Boom. What even is that? A fractal is a pattern that infinitely repeats itself at smaller scales, usually by repeating a simple process infinitely many times. The picture I have provided, oh so graciously, is probably the single most common example. You can see all the little versions on the mama fractal, all the little baby fractals. As you zoom into a fractal, it will infinitely repeat itself into perpetuity. Some of them. Some of them are infinite, some of them aren't. I put infinitely there because they happen to be infinitely, but like some of like the real world ones aren't because nothing like with the some things are infinite, like broccoli, which we'll get into. Don't get me wrong. All right, trust me. Just bear with me. Broccoli is not infinite. Once again, that will make sense. Infinite, not later. It will make sense later. It is nothing more than a shape that is another shape over and over again. All right. Now, if you'll excuse me for just one moment while I refer to my notes here. Examples. What does that even look like? Look at that. Exhibit A, snowflake. Exhibit B, a fern leaf. A much better example in my opinion, because it's just a bunch of the same leaf over and over again. Now, on the right, Exhibit C, the broccoli in question. The Romanesco broccoli is what it's called. I hate it. I think it's freaky looking. I hate looking at it. It's like the best example of a fractal in nature. I hate it. I hate it so much. Looking at it makes me uncomfortable, and I'm going to change the slide now because I hate it. Okay. How does that even happen, Ben? How is that even possible? Iteration is the magical golden word. Down from the heavens. All right. Iteration is nothing more than the repetition of a rule or shape as many times as defined into perpetuity. Meaning, TLDR, you take a thing and you do it as many times as you're told. Thing being the rule or the shape. Repetition, like rule, pattern, like anything. Shape, just put a bunch of triangles on another triangle, a bunch of little baby triangles on the mama triangle, Sierpinski triangle. Boom. Another really big fractal. In both scale and in size. That's the same thing. You know what I meant. I trust you. Why does any of this even matter? That's a good point. Fractals help us understand chaos and complexity in a mathematical form. Something that we have never been good at, ever. We still aren't, frankly, but we're a little better at it thanks to fractals. Most of the time, they do things that geometry can't, which we'll get into. Just know that you can't make some of these things out of squares and triangles and circles. I'm not squarist. All right. Can't do stuff with simple geometry. Like a bunch of simpletons. Except for my goat, the triangle, but you know what? We don't even have to get into that right now. Who even uses these? You do, my friend. Antennae and technology. The picture there is an example of a fractal antenna. What it is it's just the same pattern, repeatedly, in the form of an antenna. They are usually, the most widespread thing that they happen to be in is a smartphone, obviously. Guarantee you're holding one right now. All right. I know you. Wi-Fi, Bluetooth, satellite communications, all of it. And thanks to how much antenna is being packed into such a small square, quote-unquote square, on the circuit board, it can do so much because of how much it is. There is so much antenna in such a small little spot that it's rocking and rolling, brother. It's game time. Meaning multiple frequencies. Bluetooth as a whole, which might be black magic. I don't know. I'm a mechanical engineer. I'm not an electrical engineer. I don't know what any of that means. Wi-Fi, also black magic. I'm not an electrical engineer, but apparently fractals do it. Meaning fractals are also black magic. And having looked at pictures of them for the last like 3 weeks, can confirm that they might be black magic. Because they're freaky looking, like the broccoli that I don't want to look at again. In fact, I just brought it up. I'm thinking about it now, and now I'm upset. We're going to move on. Boom. Image compression. Now, this one was really, really hard to get an example of. So you're right now, you're looking at the right side of your screen, and you're like, wow, Ben, that's a lot of pictures and a lot of numbers. I don't even know what it means. I felt like I had to add something. So I added something that like somebody much more educated than me might be scratching their chin and going, yes, that makes perfect sense. To me, it's just a picture of a woman over and over again, which is probably the point, frankly. But anyway, when you take a picture, your phone compresses it. Pictures have a lot of data, so they're really big. But obviously, it's impractical if they're really big. So, you squish it. And it can either be squished pixel by pixel, or it can take patterns that are repeated and squish the patterns. Patterns, iteration, ding, 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 fractal compression. I think that it's been deprecated in a manner of speaking. I don't think we do it anymore, but we used to, and it was really good. Moving on. Now, okay, I'm going to warn you. It's about to get really gross, because we're going to start talking about medicinal use. All right, so no blood. It's just, again, a little freaky looking. Not as freaky as the broccoli, but I'm going to stop talking about the broccoli now. I hit the button twice. Ah. Medicinal purposes. This is the big one. This is the really big, important one. If you're ever like, oh, what are fractals used for? This. Fractals are quite frequently, used to identify and diagnose patterns in things like neural structures, blood vessels, and the internals of the lungs. Which is also just blood vessels, but there's more in a lung. Right, and you'll notice in the pictures here, top, there's 2 pictures. I know it looks like 3, it's 2, I promise. The top picture, lung diagram. One without blood vessels, one with blood vessels. And you'll notice, it looks like a lot of the same pattern, iterated over and over again. Ding, 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 there's the golden word, down from the heavens. Second picture, bottom picture, blood vessels in the heart. Another big one. Heart and lungs are the 2 biggest fractal analysis subjects, in a manner of speaking, in the modern medicinal era. Fractal analysis is literally what it's called. Doctors, studiers, researchers is the word I'm looking for there, not studiers. Studiers isn't a word. Researchers is a word. Use this quote-unquote fractal analysis to diagnose and study heart rhythms, tumors, especially in the lungs, just given how dense the pattern is, so on and so forth. And neural structures, I don't understand that one as much because brain stuff is incredibly complicated. And again, I'm a mechanical engineer. I'm not a doctor. All right. So, take everything I'm saying here with the amount of salt that you would usually use in a presentation, frankly. But okay. Low-com recap. Fractal antennae, Wi-Fi, Bluetooth, communications. A lot of antenna in not a lot of space. Very good. Muy bien. Boom. Image compression. We don't really do it as much anymore, fractal compression, but it's a thing that we can do in theory, and it's pretty cool. Lungs. Super complicated. We can make it simple with fractals. Thank you.